what we ended up with last period was at least an outline and just the beginnings of how we can write code that will sort this list. The basic strategy we're using, by the way, is called an insertion sort. So what we did yesterday, these numbers are what I did for the other class because I erased them and let's try that again. Duplicate. Alright, there we go. So once again, this is where we left off last time. We had an outline here in comments of the process or the algorithm for sorting. We were starting to write the code, and if we come over to the notes, one thing I do want to point out is that the approach that we're looking at here is called an insertion sort. And the basic idea behind the insertion sort is basically you want to repeat the following process. Find the next smallest number. So initially that's the smallest number. Put it in the next available slot. That's the essence of it. So you go through the whole list, find the next smallest number, put that in the top slot, or find the smallest number, put that in this top slot, go through the rest of the list, find the next smallest number, put that in the second slot, go through the rest of the list, put that in the third slot, and so forth. That is the insertion sort. Another word you might use for it or phrase is the champion sort, where you think of the smallest as being you're looking for the champion. You insert that at the top. Then each other element in the list is sort of a challenger or a candidate to be the champion. So let's come back over here and look at our strategy. And so we're basically setting up an outer loop. Each outer loop finds the next best or the next smallest number to put into the next position. So that loop, basically we have a loop variable that is keeping track of what position in the sorted list we're trying to fill. I'm calling that the fill index. Then we had just started, and I came up with the name candidate index, but let's call it the challenger index. I like that better. You can of course come up with your own name for it. You might just want to call it I if you don't like a lot of typing. I will say that in general it's a good idea to carefully choose your variable names when you're programming. This is something I will start harping on more and more as the semester goes on. Just picking, X, Y, A, B, I, J for things may seem convenient, and nobody wants to type 20 letters when you can just type one. I understand that. But in terms of both making it understandable to anybody else who has to read your program, such as your instructor, or in the real world, if you're actually a programmer professionally at all, you may be writing stuff that other programmers have to look at, and then they have to debug it, or they have to change the way it works, etc. They will get really mad at you if you don't write programs that are easy to understand. And choosing variable names that very carefully express what that variable means, what that variable represents, is very important to making it easy for other human beings to understand your programs. So that's why I try to do that when I'm showing you examples, and it's a good habit for you to get into. So now we need to think about how this challenger index is going to work. But the essence here is we want a loop here that finds the next smallest number. So basically, if we come back over here and think about the strategy, let's say we've already got the 3, that's the smallest, filled in here, and the 16, this is already, no, this is not sorted yet. I think I have them sorted over here, except I don't have a 3 in here for some reason. I have a 7, not sure why. Okay, let's make that a 3. But let's say we have locked in, say, the first 3 numbers or something like that, or at least the first 2. Like here and here, 3 and 16, those are the 2 smallest numbers, so those have been locked in, and we're ready to fill position 2. So that would mean our fill index we've gone around that big loop twice already, and our fill index is now 2. Then what we would do is we'd say, well, the 91 that's in there, that's our sort of our current champion. All right, and then we're going to go through the rest of the list and try to find smaller numbers than the current champion. That's the basics. So we probably want to start our challenger index right there at that 91, or maybe at the next one up. So let's just start the challenger index at whatever the fill index currently is. And we may need to go, we might as well go +1, because obviously comparing the number to itself, comparing the champion to itself doesn't really make much sense. So if that is how we define our challenger, our champion is whatever is in that fill index position. So I'm going to say champion equals fill index, or equals, what is the name of our array? Our array is numList, so numList, and then we pick box fill index out of numList, like that. And that is our champion. And there's another thing we're going to need to do here, which is eventually we're going to find that the champion is this 18, right? So we start out, the champion is 91, and then it's 31, it's not 77, 31 is the current champion, not 33, 18, that'll be the current champion, 44, 19, 83, 22, so 18 would become the current champion, right? But we need to know not just what the current champion is, we need to know what position it is in the list, so that later I can just swap the 91 here with the 18 there. Okay, so I want to keep track of the position of the champion as well as the value of the champion. So I'm going to have another variable called champion POS for position. I think I will not write that all the way out. We could write it all the way out, champion position, or actually I think I'll stick with index. Since I'm using index everywhere else, let's use index for that. So I'm going to say champion index equals the fill index. So again, all that is doing is saying is that if I'm ready to fill position 2 here, I'm starting by assuming the number that's already there is the current champion. And then I'm going to look for something better to put there, something smaller to put there. So we start with those 2 things. Now we're ready for the inner loop. So we start with the challenger index as the fill index +1, as long as I don't have a typo. And the challenger index is just going to go up by 1 up to the last position. So challenger index should be, we want that to be less than the size of our list. So how many? And then we want to say challenger index ++. And so this makes my lines of programming code kind of long, but it's very clear what I mean by things with these long variable names. What I will say on that subject of long variable names, maybe you really are sick of, I really don't want to type challenger index every time I use this thing. So let me show you one thing that's good style if you really don't want to do it. So suppose I want to say CI for challenger index. Well, if you're going to do that, put a comment somewhere like CI, challenger index. Okay, that way you can kind of create sort of a dictionary. So if you use short variable names, abbreviations, and so forth, create comments that make a dictionary or an explanation of what your variable names are. That's at least one way of kind of getting the best of both worlds, not typing so much, or and having good variable names. I'm going to do undos though back to the way it was. Oops. There we go. So now, what do we want to do inside this inner loop? Well, we want to take the challenger and see if it's smaller than the current champion, right? So that's, and then depending on whether it is, we want to do different things. So I'm going to have an if, because we need to make a choice based on whether the challenger is smaller. Now, what is the challenger? The challenger is the number in our numList array in the box indexed by challenger index. So I want to say numList box challenger index, and I want to ask, is that smaller than my current champion? And if it is, then there's something I want to do. What do I want to do? Well, I want to say that the current champion is now that number. So what I want to do there is say champion equals numList challenger index. Like so. But I also need to remember the new index of the champion. So again, looking at the example over here, when I get to the 31, that's at position 3, so I basically want to remember the 31, and I want to remember the 3, so I store those in my champion and champion index variables. So champion index equals the challenger index now. So I take the challenger index and replace the champion index with that value. So now if this loop keeps going until the end of list, by the time we're done, we should have the smallest value in the remainder of the list and its index. So now we're ready to swap that value into the fill position, into the box for the fill position. So again, looking at the example, once we find out that 18 in position 6 should be the replacement for that 91 in box 2, we actually have to do that replacement. We want to swap them because we don't want to lose the 91, so we'll put the 91 where the 18 is, we'll put the 18 where the 91 is. So how can we do that? That's a fairly basic swap operation. And the question is, when do we want to do it? We want to do it after this entire inner loop completes. That inner loop goes through all of the list from the fill index down to the end. Then we've found our new champion to replace what's at that fill index. So then after that loop, now we're ready to do a swap. So what we can do here is say, I'll actually throw in a comment. Now swap the champion with whatever is in the current fill position. So this just takes a few steps. The thing you might jump in and try to do is, and we'll do it this way first and actually test it and see what happens. So I'm going to do it wrong first, a little bit wrong. We're going to say numList box fill index. So we're picking out the box that we want to store a new thing into, and I'm going to say that equals champion. Okay, so that's great. That will take the 18 and put it in box 2 in our example here. And then we will say numList box champion index and say that equals num list box fill index, with the idea there being that we're taking the 91 and putting it where the 18 is, right? Make sense? Does anybody see anything wrong with that yet? Since I've telegraphed that I'm deliberately making a mistake? Do you see what's wrong? Do you see anything wrong with this? Oops, well, there's one thing wrong. Oh wait, I'm looking at the wrong line here. Okay. Do you see any? So these two lines are supposed to do a swap. Does anybody see a reason why that's not quite going to work the way I'm advertising? All right, let's go ahead and save, run, and see what happens. If it does do the swap successfully, then we're pretty much done here. This whole thing will do the sorting. So I'm saving that. Let's go ahead and rebuild. Make sure I fix any silly mistakes like forgetting to declare my variables. I have champion, champion index, challenger index, 3 new variables I made up and then did not declare. So let's throw another declaration line up here. So we have challenger index, champion index, and fill index. Champion, and we have champion. Okay. And champion. Hopefully I typed all those right. So let's come back, build, and looks like I redeclared fill index twice. So I already had that up here. Let's take that one out. And looks like I had this variable smallest so far that I was going to use, but now I came up with the name champion for it. So let's go ahead and take that one out as well because we don't need it. And whoops. Oh wait, it looks like I am using that somewhere. We'll figure that out in a moment. Do I need to printf the numbers? Printf what numbers? You mean print the sorted list? Oh, well, we already had that down here. Oh, this is why we had that smallest. Remember, we did this example right at the end of last class of just going through the list and finding the smallest number in the list. That's why I have that smallest so far variable there. But here is just the printing of the list. We already had that down there at the bottom. Okay, so this is just back to what we had from last class. So actually right here, let me take this stuff out. This was just, we put that in there because before we did the sorting, we wanted to look at how do I just find the smallest number in the list. And we had this working right at the end of, or about 10 or 15 minutes before the end of class last time. So don't want to just keep that permanent deleted, but you probably have that in your version of this as well. Just copy and paste it down to the bottom and then put it all in one big multi-line comment. Use the star slash star star slash. Just if you want to keep that around for reference. So let's get that out of there, and then we can challenged you all to see if you could do it on your own. Let me get some blank lines out of here. And so here we have what should do the sorting if these couple steps to do the swapping actually do their thing. And now we really don't need this smallest so far variable, so I can once again take that out. And let's rebuild and see if there's any other build errors. No more build errors. So let's try sort numbers. How many numbers will be in your list? Let's keep it small. Let's say 6. And 32, 99, 16, 15, 14, and 27. And here's what we get: 14, 14, 14, 14, 14, 27. Interesting that they weren't all 14s, but clearly somehow it found the smallest and got that in the first position, but then it ended up duplicating it over and over and over again instead of swapping numbers around. So there's something wrong with the swapping. So let's think about what these two lines do. So let's say again, let's come over to the example. Let's say our fill index is, these are the variable names I used with last class, so I should give myself the lecture on variable names that mean something, right? Let's see, let me make that bigger. Is that readable? Yeah, that should be readable. All right, so the fill index is 2 right now, if we're looking at this position. And let's suppose that the champion index is then 6, because the 18 is the next thing we're going to fill in. And so the champion index is 6, and the champion is 18. So what we're trying to do is swap the number here with the number here. Okay? But let's look at what I did. Let's just look at it, what the instructions actually say. This one says take the value of champion and put it in the fill index box of numList. So that would, if I come back over here, that would say take this 18 and put it here. What has happened? I've erased the 91. It's gone. It's gone for good. There's no getting it back. So when we get to that next line, what's going to happen? We're going to say take numList box fill index, so that's numList box 2 over here. So we're going to take the number that's in this box and we're going to store that into this box, numList box challenger index or champion index. So we're going to take this 18 and copy it to where there's already an 18, basically. And so now I've just ended up duplicating the 18, not getting the 91 moved down there first. So how can I fix that? The problem is that I took the champion and put it into the fill box first, erasing what was there before I took what was there and put it where it needed to go. So the question I'm posing to you is, how can I fix that here? It's not really a trick question, so if you're thinking, well, this is too obvious, it's not a trick question at all.
You just flip them?
Yeah, you just do the other one first. So if we come back over here, all I need to do is take the 91 and put it down here first, because I have the 18 already stored over here. That's the number that I want to move into this position. So if I just do the first thing first, or if I do the second thing first instead of second, I would copy the 91 down there, and then I would copy this 18 into there. And then I haven't lost the 91. So all that means over here is doing this line first. Oops. If I can do my cut and pasting correctly, that is. Yeah, that's what I wanted. So now I'm just making sure that I copy. So again, if I hit undo over here, if I copy the 91 to its new home first, and then take the new champion and replace the 91 in that order, then I'm good to go. So let's save that, build, and let's try 6 numbers again, and let's go with 88, 44, 22, 11, 1000, and 4. So we get 4, 11, 22, 44, 88, 1000. All nicely sorted. And you should always test these things a few times. Let's go with a little bit bigger list. Let's go, say, 10 numbers. And let's go 5, 99, 16, 17, 12, 4, 1000, 500, 250, 125, and there we go. So we get 4, 5, 12, 16, 17, 99, 125, etc., and all nicely sorted. So that is sorting. What I really want you to get out of this is several things. One is the idea of a loop within a loop. Now, hopefully in your 150 class or equivalent, you did have to do some things that required one loop inside of another loop. Did anybody not have to do that for at least one programming problem? Yes? No? Did you have a question?
I did. He was raising it and then
Oh, okay, right. So the question is, did anybody not have to do that in 150? Okay, good. Now this is a little bit, probably a little bit more elaborate than what you had to do. Maybe not. Depends on how painful your instructor liked to make things for you, I guess. But you have a number of other things going on. Notice how we're using 2 different variables to index into an array. So we're having 2 separate integer variables, each of which we use as an index into the array, and we use each of them in a different way. One represents, this is the position that I want to move a new number into. The other one is, this is where I'm looking at different possible numbers that might move into that. And then we actually have a third index variable that is where we actually keep the index of the thing that we're going to swap. Okay, so we're actually not 2 index variables, but 3 different index variables, all indexing things in the same list, and all potentially at different indexes, having different index values. So I want you to kind of just get that. Really, if you're not following just from sitting here in class, take this, okay, go through it step by step by step by step, until you really understand how it works and why it works. Okay, don't just stare at it and be mystified. You should take this apart in your own mind, maybe rewrite it in your own way, something, until you really get it and understand what it's doing step by step, how it works, why it works. That will enormously broaden your understanding of computer programming if you do that. If you were able to come up with this or something else that did sorting on your own, you're nicely ahead of the game. That's great. You should definitely feel good about that. So at any rate, any questions on this? Anything about this that doesn't make sense? Yeah.
I was going to say for the swapping, there was one thing that I looked up that automatically does it. Do you want us to just put in more code or can we just do like a shortcut?
Let's see. So you found a library function that did it?
No, not a library, just a swap.
Mm-hmm.
Swap function. or a data type.
Okay, so like you actually, but that would mean you created a function up here.
Yeah.
Like void, well, may or may not have said void, but void swap, and you defined.
Yeah.
That's okay, and it's not a bad idea to do something like that. I do want you to understand how to do the swapping
Inside
kind of on your own. Like, I would rather you understand how to create this function for yourself, rather than just take it off the internet and plug it into your program. So the essence of swapping is right here. Actually, I've kind of separated out because there's usually 3 steps to swapping, and then I've made it look like there's 2 steps because one of the steps is kind of hidden up here where I'm saving the champion value. Okay, we could actually take that out and then we get a more normal looking swap. If I don't keep the champion value, I can take this line out and I can take this line out. Okay, then I don't have champion here to put in there. So I have to do something else. And the way I can do that is I can have a temporary variable. I'll just call it temporary storage or something like that, and TMP storage. And then what I want to do is save the thing that I'm about to erase there. So go ahead and make this variation of the program and make sure you get a screenshot of this and testing this as well. And then I would use my temp storage variable here. So I'm going to comment out that line and redo it just with temp storage instead of champion. Like that. So this is much more of a classic example of a swap with all 3 steps right there in the same place. So we didn't actually need to keep track of the champion value, except that there's going to be one more problem, which is this comparison. What do I compare this to decide if I have a new champion? How can I change that line? Let's make that a puzzle. What should I change right here on this line to make all the rest of this work so that this comparison does the right thing? If we're not keeping the champion value, but we do have the champion index, how can I get the champion value right there to compare to?
Temp storage?
Well, we don't really use temp storage until down there.
Okay.
But how did I get the champion value to put into temp storage here? Right? So all I have to do here is numList bracket champion index, because that's the same number that I would be storing into champion anyway, right? So I can just do that comparison. In fact, I actually like this better, so maybe we'll just take those out entirely. And we'll just keep track of the champion index. That's a little, I like this better simply, especially because it illustrates the swap. Swapping 2 numbers or 2 things from one place, from one variable to another, from one place in an array to another place in an array. Very common thing to need to do, not just in sorting, but obviously in sorting it makes sense. So just being aware of this is how you do a swap. You need that temporary place to store whichever one you're going to erase first. That needs to go into a temporary variable before you erase that and replace it with the other one, and then you have that temporary variable to put back into the other position. So so that's a pretty important concept. Even without sorting, that's an important concept, an important technique to be aware of, something that can come up in programming a lot. Let's see. Any other questions about any aspect of sorting. How much time do we have? Let's see. Oh, good. We're doing pretty well on time. Okay, I'm going to pose a question to you. This is a little bit of a mathematical question. I want you to think about if you were sorting a list of 10 numbers, how many times is it going to do this comparison? Basically, how many times is it going to come into this inner loop, right? And check whether or not, you know, find the next champion. How many times is it going to repeat that stuff? The stuff that I have highlighted, how many times will that be repeated? Let's keep it really simple. Let's say the list is 5 integers long. How many times is this inner loop going to be repeated? Just how many times am I going to do the stuff that's highlighted there?
25.
You're in the right ballpark. You've got the right idea. But let's think about it. The first time when fill index is 0, this is going to go from 1 to 5, or 1 to 4, right? Because the indexes go from 0 to 4. So this is going to go from 0 to 4. So the first time through the big loop, we're going to hit this stuff 4 times. Then fill index is going to go up by 1. So the next time we're going to go from 2 to 4. So we're going to do this 3 times. Then we're going to do it 2 times and 1 time. So that's 1 plus 2 plus 3 plus 4. We'll go 10 times. Okay. Now you're really actually, when you did 5 squared, you're sort of right. You're thinking the right way. Now let's say the size of the list is 10 numbers. Well, then we're going to do this 9 times plus 8 times plus 7 plus 6 plus 5 plus 4 plus 6. That's going to be, I think, 55. You can double check me on that. Okay, so it got bigger quite faster. What if the list was 100 numbers long? Well, that's 100 plus 99 plus 88 plus It's approximately 100 squared divided by 2, so that would be about 5,000 times it has to hit that, right? What if it was a list of 1,000,000 numbers? Well, that's going to be approximately 1,000,000 squared, which is 1 trillion, so it's going to have to hit that 500 billion times, approximately. Okay? And computers routinely sort lists of well over 1 billion things. Happens all the time. That starts to take a long time. Even when these steps only take nanoseconds or microseconds, once you start adding up trillions of nanoseconds, the computer starts to, that's when it takes a minute for it to get back to you, or an hour, or 10 days, or whatever, depending on how big the lists are and what you're actually having it do. Why do I mention that? Is that a big chunk of computer science is thinking about how you can write programs more efficiently. So something, for those of you who really like kind of a mathematical puzzle, challenge, whatever, see if you can think of a way to really cut down on how long it takes. So if your list got really long, could you make this much, much, much more efficient? And I would say, you know, before you Google or anything, because this has been studied since, I don't know, the 1940s, since the invention of computers, people have been figuring out better ways to sort things. So the answer to this is out there. But I think it's a worthwhile puzzle if you like that kind of thing to think about how could you really make this a lot faster. So if you had a list of 1,000,000 numbers, instead of it taking 500 billion comparisons and swaps that you have to do, can you cut that down to, well, actually, for 1,000,000, it might only be like 20 million. And 20 million instead of 500 billion is like a factor of 1,000,000 times faster. Okay? So could you make this run 1,000,000 times faster on a list of 1,000,000 items? That's kind of the question I'm posing to you. And the answer is yes, it's possible. And one way to think about it is if you had a large stack of cards with numbers on them, think about how you would actually sort that card. And make it bigger than a deck of cards. Think of a stack of cards maybe this high, and I hand it to you, and they've just got random numbers on them. And your job was to sort that because I'm evil and I'm punishing you. I don't know why you have to do this, but imagine you had that job. How would you do it? Okay, you would not do this method, right? You would not go one at a time, find the smallest and put that over here, and then start again through all the cards, find the smallest and put that. You would not do that, right? You would come up with some better ways to do it. If you click on what it is that you would actually do, you might be able to then think of a way, how could I actually write a program that does sort of the same thing? And then it goes much, much faster. So if you figure especially those of you that are computer science majors, but even if you're not, if you just like mathematical puzzles, this kind of thing, I think that's a fun thing to wrap your head around and challenge yourself with. You may not come up with the solution. That's fine, but try, think about it for a while. Eventually you may Google or ask me outside of class or something. I don't think we'll actually be able to take the time to look at the solution in class. But I do want to put that out there as something I think it would be fun if you're at all inclined that direction to try out. So let's see. I think what I want to do with the rest of the, well, let's see, we still have a half an hour. Okay, one thing I want to do is make sure that you are aware that I did post the full instructions for the first lab. And this is lab OX01. Who knows what that notation means, by the way? Does anybody know what the 0x means? Just curious whether that's something you get exposed to in any other class up to this point.
Is it like an octal? Is that a word?
Hexadecimal.
Hexadecimal?
Yeah. That's hexadecimal, and all it means in this case is 1. Anything up to 9 is normal, but 10 would be that. So this is your first exposure to hexadecimal, perhaps. That's 12, or that's 11, 12, 13, well, with a D. Wait. Yeah, D. E is 14, F is 15, and 1, 0, that would be 16. So if you're going to be a technical computer person at all, you should know what hexadecimal is. I say just Google it and start to find out now. So I just do that just to be silly, basically, in my lab numberings. But hexadecimal is a fairly important concept. We might have a programming problem or something where you do like write a program that converts to hexadecimal, that sort of thing. But that's what that numbering is. Anyway, let me talk about the instructions here. So I try to put a what to turn in section, so you kind of have a checklist of what files you should be uploading to the Dropbox. Sometimes there's some optional ones, so like one or both of the palindrome check basic and palindrome check advanced. If you do the advanced one and you're very confident that it's working just fine, then you don't really need to submit the basic one. But the basic one is a way, kind of think of it, if you do the basic one just fine and don't do the advanced one at all, you're getting like a C+ or something on that problem. And then the advanced one is for a B to an A. So we have 2 or 3 .c program files to upload, and we have a Word document that's basically kind of a showing your work kind of thing. It kind of proves that you're doing the work on your own computer and so forth. Yeah?
So on the grading, the project advances and the challenges to actually score the required grade? Yeah,
this is, if something is for extra credit, I will expressly say this is for extra credit, okay. Or I'll call it a challenge problem. So this is basically just kind of 2 levels. It gives you something to fall back on. I was writing the instructions and I was like, some people are going to be blown away by some of this complexity, so I'm like, okay, let's just do a basic version, try that first, then move on to the additional instructions, basically. So, and that's something you can do even if I don't break things down like that. When I give you a program to write, and I say it does this and this and this and this, you can always think about, okay, is there a simpler version of that that I understand how to do? And do that simpler version and turn that in. And you should add comments or explanation in your Word document telling me that that's what you did. But that's one way to go about getting extra credit, turning in a program that actually works that you can feel good about and so forth. So if you see some complexities in the description of a program, you can always kind of fall back to something simpler. So if we come down to the palindrome check program, and if you were just looking at the advanced, okay, this checks, it has this default behavior that it ignores white space characters, and it has these command line arguments that say, is it case sensitive or not case sensitive? Does it ignore punctuation or not ignore punctuation? That means you kind of have these extra if-thens that check, okay, is the command line argument, does it have a dash at the beginning? Does it have a P in it? Does it have a C in it? That's a fair amount of extra stuff to do. But the basics of just looking at a string and checking it as a palindrome is a lot simpler than that. So that comes to the idea of the basic one. And so even I may not give you like these different levels of program to write every time, but if you're looking at the instructions, if you want to fall back to something a little simpler that does most or does what seems like the important part of that program, you can always do that and turn that in, and that's another way to get partial credit. So and again, also about partial credit, just be sure to turn in whatever you do. If you did something, if you worked on something, you wrote half a program and it has errors in it, and you go and you do the GCC and you get a pile of errors, get screenshots of that, turn in what you've got, show me what you did. Okay, I cannot give you partial credit if you don't turn something in. And partial credit is much, much better than a 0 on anything. So whatever you've got done, whatever you've figured out, be sure to turn that in. So you want to turn in your .c files, and you want to turn in your Word documents, or your Microsoft Word document that has your screenshots. Generally, you want to get your, kind of side by side, the program in the editor. You don't have to show me the entire program. If it goes off the edges a little bit, that's fine. But you mainly I want to be able to see that, yeah, there it is, and over here you've done some pretty thorough testing, so you may need to do 2 or 3 screenshots to get fairly thorough testing. Don't just sort one list of 3 numbers if it was a sorting program. Sort a list of 10 numbers, sort a list of 20 numbers. Do something a bit more realistic. Do some thorough testing. So don't just test your program on a few very simple palindromes. Test several different complicated ones and so forth. That's what thorough testing means. And with the advanced palindrome one, you need to show that you tested the different options and that you saw that they work, or that they didn't work. I mean, maybe you don't get it all working perfectly, but at least show that you tested and you knew that it wasn't working. All of that is important stuff for me to see when I'm trying to give you a grade and give you partial credit and so forth. Let's see, did I mention... I guess I didn't put that in here. I think I did this for a different class, but you can upload these files via Firefox in, I thought I did say this in your instructions. I must have put this in instructions for another class. Doesn't look like I did. But you can upload for these via Firefox in your virtual machine. So that's usually a question that comes up is, okay, you've got this file like sortnumbers.c. How do you upload that to a Dropbox in D2L? Well, you've got Firefox right here inside your virtual machine. And so you can run that. And now I've got Firefox running, and you can just go to D2L from there. Let's see, what is it, sdbor.edu?
Yep.
Yeah. And you can log in and just use D2L from here. Okay, that's a way to get that. Now your Word document is probably on your Windows machine, so you want to upload, you'd have to go into Firefox there to upload that. Another thing you can do is just do like a select all, copy, and then you can come over to Windows and you could bring up Notepad. I use Notepad++, something I highly recommend, by the way. If you don't already use it, you can Google that, download it, install it, it's great. But if you just have Notepad, you could just bring up Notepad, paste your program there, save it, and then you have it on your Windows machine and you can upload from there into D2L as well. So that's two different ways you can go about transferring the file, your .c files, and getting them uploaded to D2L. Okay, so let's see, we have 15 minutes left.
When you do it that second way,
Yeah.
with Notepad, if you force the .c extension, it doesn't screw up formatting or anything.
No, you can save. Notepad can save files with other things besides .txt. It's allowed. All right, so so we got through this faster. For once, we're not like hitting up against the end of class. I want to decide what I want to talk about. Did everybody okay? Let me ask real quick. Did anybody fall behind? Is there anybody who actually doesn't have this example sorting program typed in already? Raise your hand if you don't have it. Or did you all keep up with me? Fantastic. All right. I think I'm usually leaving people behind. I'm typing too fast and it's not still up on the projector. But I will try to still copy and paste an image of this over into the notes later. So I guess what I want to do then is let's talk about, now I just talked about challenging you to find a fast way to sort. We talked about how if the list gets really long, it basically kind of the number of steps it takes to sort is like the square of the number of items in your list. It's a square divided by 2, but that hardly makes any difference. So list is 1,000,000 long, it takes like 500 billion steps, and so forth. But let's think about, well, are there other ways to sort? Just so you can kind of see, there's often very different ways to do the same thing. Okay, this is the insertion sort is one. There's another fairly simple sort called a bubble sort, and I want to kind of describe to you what that is. So I think I'm gonna make a new page over here. For bubble sort. Okay, the bubble sort, and I am going to borrow this table. So if we start with our list, and we want to do a bubble sort, now I'm going to start it without, let's say the list starts like this, with the 3 there, 44 there, and I don't want 16 there. Let's put a 55 there. Okay, so definitely not sorted right now. What does the bubble sort look like? The bubble sort basically starts at the top of the list, and if 2 numbers are out of order, if the number you're looking at and the next number are out of order, it swaps them immediately. Okay? And then you shift down by 1, and if those 2 are out of order, swap. And then you shift down by 1, and if those are out of order, swap. So let's see what that looks like here. Let me zoom in so it's easy to see what's going on. So what we do is say, okay, 44 to 55, those are in order. So we're good to go. 55 to 91, those are in order. So we're fine. 91 to 31, out of order, so swap them. So we would have a temporary variable. We'd take the 31, put it in the temporary variable. We'd put the 91 down here, take the temporary variable, and put it here. Okay, then we hit 91 to 77. Those are in order, we're fine. 77 to 33, those are not in order, so we swap. Okay, then 77 and 18, swap. Then 77 and 3, swap. Then 19, you get the idea, right? So the 77, we can see that that's the biggest, so it's going to go all the way down. So ultimately we end up with it looking like this. Let me get that. And so that's one pass through the list, and notice that it found the biggest and pushed it all the way down to the bottom by swapping all the way down. Then you do it again. You start back at the beginning, and okay, 44 to 55, check. 55 to 31, those swap. So the 31 goes there, and the 55 goes there. 55 to 91, good. 91, 33, out of order. So 91 and the 33 swap. 91 to 18, swap. 91 to 3, swap. 91 to 19, 83, 22. So the 91 would swap all the way to the bottom. And I'm going to cheat by doing this. Oh, gosh darn it, it's not going to let me do it. It's going to try and put them all in one box. That is so not fair. Maybe if I do this, it'll let me do it. Ah, dang it. Okay, so Notepad doesn't work the way I want it to. So 18, 3, 19, 83. Each time the 91 is being pushed down here, 22, and then the 91 ends up in the next position. And then, of course, that's smaller than 777, so we don't push it any further. And then you go back to the top, and you do the same thing. 44 and 31, they're out of order, so you swap. So the 31 goes there, and the 44 goes there. 44, 55 in order, so they're fine. Then the 55 swaps, swap until it hits the 83. So the 55 would stay there, the 83 would swap down, and so forth. So I'm not going to work through that further. Hopefully you get the idea. So I think it would be a good challenge. In fact, I might pose this as part of the next homework assignment. Try and write a program that does the bubble sort instead of the insertion sort or the champion sort. So it's not really that much different. It's just a loop within a loop, and it's just kind of how you decide when to swap and what to swap is what changes. In the insertion sort, you just had one swap after the inner loop. Okay, so we figured out what the next champion was, and then we just swapped the champion to its position. With the bubble sort, you're actually doing swaps inside the inner loop as you step through. You're looking at this thing and the next thing and deciding whether to swap them, and you do that over and over and over again inside the inner loop. Then you come around the big loop, and then you do it again, another pass all the way through. And you also have to keep track of whether or not you've done enough passes, total passes through the big loop. So that's the idea of a bubble sort, and so I think we'll leave that as a challenge. So what I want to do is, instead of just say get out of here, although I think I'll maybe let you guys do that if you want to, is go ahead and take a look at the lab instructions. Why don't you, if you haven't yet, let's do this now. actually read these. You should read the full instructions. I know I write very long instructions, but that's so it thoroughly explains what it's supposed to do. But there's always people come up with questions anyway, no matter how hard I try to make the instructions perfectly clear. So read the instructions, make sure you understand, and maybe try to get a start right now on the homework if you haven't already, and ask me questions with the time remaining. And yeah, that's it for today. Okay?
Do we have to do a scan F before the beginning of the main program then to suppress the welcome message?
Yeah.
No. The welcome messages are these things up in the general requirements.
Yeah. Unless you start reading the program.
So that's just, welcome to my, palindrome checking program. All right. The -Q is just don't print those messages. So it's something you don't do, not something you do.
You type the -Q into the.
Okay, when you run the program as a command, you type dash. You'd be like, pow check -Q, and then the file name of things to check, right?
Okay.
Or the strings that you're going to check for being palindromes.
Okay.
Yeah.
And
then if the -Q is there, then you don't print welcome to my palindrome program.
Did you add that like -2 to make sure the enter doesn't get? Remember that tip you told me?
Oh. Yeah, so we had one question that came to my office hours. Since people are already living, I'll add some tips. One thing to watch for on the lab page is I will add like a sub-page. As questions come into me, I'll add tips if I think it'll benefit the entire class. There is one already that I'm gonna put out there, so watch for those.
Got it.
All right.
Do you want us to turn in this week's screenshots with that assignment, or just?
No, the screenshots, the classwork screenshots are always a separate Dropbox. They don't go with the assignment.
Is it open? Is the Dropbox open already?
If it is, I'm way more on the ball than I usually am with that sort of thing. So probably not. I don't remember creating either Dropbox yet. I should maybe do that now. That would be a good thing to use this time for.
So that second one for the bubble sorting, would that be any more efficient then?
It's actually about the same.
Yeah, that's right.
It ends up being about the same.
Because you're still looping through about the
Yeah,
same
you're
amount of time.
you're going through
You'd have to go through
all of the lists, then one less than all the lists, then one less of all the lists. So you're really basically doing the same number of steps. It might be off by, a very small
slightly
amount.
depending on the
but,
order.
yeah. Now there is a trick with bubble sort where you can spot the fact that you didn't do any swaps at some point, and when you know you've never done any swaps, you can stop before you've done as many passes as you might have otherwise. But that doesn't really save you that much. It's not the solution that I'm talking about that just really
would really
drastically
cut it
cuts down. Think about the stack of cards, and you got a big stack of cards, you want to sort them. How would you actually go about doing that as a real person in the real world? Even a simple deck of cards, you can, just a normal deck of playing cards, you can kind of think about what you would do. Like you might split them into suits first and then sort the small stacks. That's kind of a hint. That's the approach.
Hundreds or something first?
Yeah, you're on the right track.
Bunches instead of all.
Yeah. There's different approaches, but it always involves kind of splitting it up into smaller pieces and then kind of recombining those smaller pieces. That's the general idea. But it is kind of a tough problem, but it's worth thinking about at least a little while before you go up and find the solution written down somewhere.
Or just Google
Yeah.
that. All right. Have a nice weekend.
Yeah.
Thanks, Scott.
See you Tuesday? Tuesday. This is 250, so I need drop boxes. And so we need a lab OX01.
Would you need that argc and rv to do that dash p, c, or q?
Yeah, so those will be command line arguments too. So I mean, command line arguments are just strings coming in, right? And you just have a list of whatever strings there are.
You don't need both of them though, right?
Well, one argument. So there's a few. Actually, I should probably create some examples so you can actually see what it would look like. But
I don't think I fully understand what those are.
Yeah, let's let me show you what command line arguments are in general, or
Does it have to be in argc and char star argv?
well, that's where they will be. So let me show you first what it would look like when you type your program in. So you could do it without command line arguments. So this would be like input file.txt or whatever. And oh wait, no, we're not doing input files. So so this is like ABBA and AB plus AB or plus AB, AB. So that would not be a palindrome. Or if you wanted to have spaces in it in a command line argument, you could do, you know, a man, a plan. That's not the whole thing, but whatever, you get the idea. Yeah. So that would, you would want it to check each of those to be palindromes. If the first one has an option in it, like -p, then you would check those, then you would look at the rest of them and check whether they're palindromes, but then you would ignore or include punctuation.
I don't even
okay?
need to ask them to enter.
Right, you don't ask them for the options. The options are part of what goes on the command line.
No, but I wouldn't even ask them to enter the ABBA.
Right, that's the whole idea is you're looking at command line arguments and deciding if those are.
Okay.
No, it's not.
Yeah, so that's part of this assignment is, again, getting more comfortable with command line arguments.
So then I would do a fgets for the RV then?
I don't think you need to do, there's actually no scanf or fgets that you would need to do.
Oh, you just throw.
So argc and argv are given to you, okay, based on this, how you enter the command. So actually, it would probably be / in front of there, but, so you would run it like this. Pow check, and probably you call it basic or advanced, whatever. So pow check basic, so you'd run it like that. So remember, that's just how the operating system works. You enter a command this way, and it sets argc and argv for you. So all those argv string values and the count of how many there are all set for you already. So as soon once you get into your main program, those are just there already.
Okay.
Make sense?
So the C counts how many there are, and the argv will check if they're palindromes, right?
Well, no, the argv will be the strings that you have to check.
Why is it an int then?
Argv is
Oh no, argv
is a pointer to pointers to strings is technically what it is, but you can think of it as an array of strings. You may want to go back to our previous examples of using argv and argc.
Yeah, that's what I was
And you can also just Google C programming, how to use command line arguments. You'll find a jillion tutorials and examples and whatnot. Glad at least one person actually takes advantage of a chance to ask questions. It's like everybody else left.
My guess is not very many people have started yet.
Yeah, but I mean, this was 10 minutes where they could have read the instructions to see if they even understand the instructions. Because I think the questions you're asking are making me like, okay, there's going to be plenty of other people who also don't quite get what I mean about the command line arguments. So right now, did you have it reading the lines with fgets?
Yeah, I figured out what the problem was. One of them was that when I typed in that L end and R end at the bottom of that, I put the R end as plus plus instead of minus minus. And the problem I was having is I put 2 equals instead of 1 equals in that if statement. So so I figured it was working and everything when I was typing in, when I asked him to type in 1 and then that was working.
And what another thing that, to be aware of, so that's actually what something that threw me when you were asking me earlier, because you were using an fgets to get the lines. That's why you're having that new line character at the end issue.
Yeah.
But if they're I was forgetting, it was always supposed to be command line arguments, then you don't have the new line in the command line arguments.
So then I would just do that.
So
-1.
So then it'll be -1, not -2.
So I guess theoretically you wouldn't even need to put that tip in.
Right. Yeah, I actually don't need that. Actually, the tip I need to do is to make it much more clear what I'm talking about with the command line arguments. That's the tip that's needed. Sure, if there's people waiting to come in or not. You in the next class? In here? Okay, we'll get out of your way. We're done. You can come in if you want.